So in my previous lecture, I have discussed three different approaches which we will be using for decision making under uncertainty. So connecting with that lecture, now I am going to bring some more changes in the question, in the example which I have already discussed in my previous lecture. So now the changes which are now I am including in the previous statement, that suppose that the stable at which we are planning to get the horse trained suggests the following proposal. The stable will provide the training at a lower cost, with the condition that if the horse win, then they get a third of the profit, but will not charge at all for the cost of training. If the horse lose, then we have to pay only 50,000 for the training. So now this is another state of nature. Before we have only train or not train. It means not training means sell it. Now there is another offer. Offer from where? From the stable. They will not charge for the training, but if the horse win, then they will charge 1/3. You can see 1/3 of the profit. So mean 800. So 800 will be. So how much you will give to the stable then? So 800 into 1/3, 1/3, which will be 266.66. So if your horse win that game, you will pay 266.66, which is equal to 266, and the remaining will be 533. So the new payoff for the problem are summarized in table 5. You can see we now have three possible decisions. So we have three possible states now. To sell it directly, which we already discussed, the pessimistic. I don't want to go into the trouble. I don't want to go to take risk. I don't want to train my horse. Just sell it out. So I mean in that scenario, it will be 100 and 100. To train the horse, but not make the agreement. Okay. The agreement is not good. Okay. Don't go for that. Just train it from your own side. But there is too much risk. You can see. If you win, definitely you will get 600,000. But if you lose, in that scenario, you will lose not only minus 200,000, but you will also lose the horse price, which is currently, if you want to sell it, 100,000. So this is the losing. And if you accept the offer from the stable, and the stable will provide the training at a lower cost with the condition if the horse win, then they get a third of the profit, but will not charge at all for. So there is no charge for training. But if the horse lose, then you have only to pay 50,000. So as I already mentioned, if your horse win, so 800, you will pay 1/3 of the profit. So 1/3 of the profit is 266.66. So you will pay this 266 to the stable people. So 800 minus 2. So again 533, 100,000 of dollar will still coming into your pocket. But if you lose, so you need to only pay minus 50,000, only 50,000 for the training. So now the question is, and this is the horse expert probability, that the winning probability chance is 0.6 and the losing probability is 0.6. So now let apply those three approaches. Which approaches? The first one is maximum approach, the second one is most likely approach, and the third one is the expected payout approach. So if we use the maximum approach, so which one is the minimum in these two states? Win or lose, so minus 200 if you want to sell it, and which one is the minimum one? Minus 50. So what should you, now you need to choose maximum from these. So which one is the maximum one? This one is the maximum one. So maximum approach give us pessimistic. Just sell it. Don't go into the risk. Okay, most likely, which is also called optimistic approach. In optimistic approach, we have firm belief that our horse will win. Okay, if your horse will win, then you totally rely on the probability. So the probability is very high in this one. Okay, so this is 600. In this one 100, this is this, and in this one accept the offer, the probability is this. Mean the probability is high, so I mean only relying on the highest probability. And the highest probability, if we train it 600. If we sell it 100, if we accept the 533. So now in this, most likely we need to choose the maximum one. So maximum shows that go for training because you earning more money. But this is also not more realistic one, okay? The third approach is the expected approach. So expected approach, how it will, we will get this 0.6 into 600 plus 0.4 into minus 200. So it will be equal to 280. How you will get this one? Okay, 0.6 into 100 plus 0.4 into 100. So you will get 100, this one. Okay, and for this one, which is equal to the probability for this nature of state is 0.6, 0.6 into and 533. So 533 plus the nature's probability is 0.4 into minus 50. Minus 50. So this is the payoff. So now you need to choose the maximum one from this one. If you train, there is too much risk. There is too much risk, minus 200 and minus 100 of the horse price. So in this one, still something is coming into your pocket, 280. But there is also some risk. And this one is the 100. You're not going to the training, and if you accept the offer, 300. So now in this scenario, we need to accept this one because there is not too much risk involved and the payoff of this state is very high. So if the maximum approach is used, then the optimal decision is to sell the horse directly. This is called risk averse. Okay, if we use the maximum approach, don't go into the risk, don't go into the training, don't go to accept the offer, just sell it out, which is risk averse. If the maximum likelihood approach is used, then the optimal decision is to train the horse but not accept the agreement. So you can see from this one, don't go, don't sell it, don't accept the offer, just train it because the payoff is very high. This is high risk because there is too much risk. Minus 200 this one, and minus 100 the horse price. So this is too much risky. But if we apply the maximum expected value approach, the optimal decision is to train the horse and accept the offer from the stable, which is risk neutral. So this approach is very risk neutral. You can see this one, and the payoff we need to go to accept the offer because there is not too much risk involved and we will get most optimal solution. Thank you.